right? The graphs of polynomial functions, which is the title of this lesson anyways. You know, and this is pretty important to understanding where we're going with polynomials. Okay. All I've got on the slide right now is up through quartic, right? But we know that by linear, we expect a linear function to either goes up or it goes down, right? Understand that if it was constant, it would be flat, but we're not talking about that. So it either is going up or it goes down. How do you know, based on the equation, how do you know whether it's going to be tilted up or tilted down? Say again? Right. So this one is the slope, is greater than 0. This one is the slope is less than 0. We already know about quadratics. We're familiar with the standard form of a quadratic function. The shape of the graph is a parabola, and it either opens up or it opens down, right? How did we know whether it opened up or down? Erica? Say again. Okay. If A is greater than 0, you get this one. If A is less than 0, you get this one. Right? Okay. A cubic function has one more turning point than a quadratic function, right? A quadratic function just turns once. A cubic function can turn twice. So here's your 2 turning points. And because it turns twice, it either starts out in negative numbers and ends in positive, or it starts in positive numbers and ends in negative. What do you think will be the determining factor on whether it does this or this? I mean, what was the determining factor on these? Steps, right? So this is the one which is A is greater than 0. This is the one of A less than 0. I mean, notice the difference between, or the similarities between linear and cubic. Both of them start in, either they start in negative territory and they end up in positive, or they start in positive territory, they end up in negative. Right? If I go to quartic, quartic can have one more turn in it, right? We went from no turns to 1 turn to 2 turns to 3 turns for a quartic. And because you're turning 3 times, that means it's going to either start out in positive territory, turn once, turn twice, turn 3 times, and go back into positive territory. Or it'll start out in negative territory, turn once, turn twice, turn 3 times, and end up in negative territory. Again, what do we think is going to determine whether it does the first or the second? It's about A, right? Just like it was about A here for a quadratic. It had the same similar kind of shape, right? It either starts positive and ends positive, or it starts negative and ends negative. This is when it's greater than 0. This is when it's less than 0. I mean, just following the pattern, what do you think would be a quintic? How many turning points do you think we would get for a quintic? It could be 4 turning points, right? And would it be more similar to a quartic, or would it be more similar to a cubic? To the next lower odd function, right? A quintic would go like that, right? 1, 2, 3, 4 turning points. Peter, what you got? C, yes, that's it.